Now we will do for 2010 Math 227 test 2 number 4. The chips of a computer manufacturer are supplied by 3 companies. 40% from A, 35% from B, and the rest from C. Now, 40% here, 35% here, the total is 75%. The rest here must be the 25%. Right? Now, of those supplied by A, 1% are defective. Of those supplied by A, that's the given, defective given from A. Okay, now the 2% here, by B, 2% are defective, means defective given it comes from B. And part C, by C, 4% are defective. Defective given that it comes from C is 4%. Okay, if I write it completely, it will be probability of being defective given that it comes from A is 1%. Probability that it is defective given that it comes from B is 2%. Probability that it is defective given that it comes from C is 4%. Now that's the situation. Now part A, construct the 3 diagrams of the situation. The first one is that you will have 3 branching because it comes from 3 different suppliers. Suppliers A, B, and C. Okay. Now the tree diagram is done in the following way. Remember that the events is written at the end of the branch. The probability is written on the branch. Now what percent comes from A? 40%. And then from B is 35%. From C is the rest, right? 25%. They should add up to, each time you see branching, they should add up to 100%. Now, of those chips coming from A, 1% are defective, which implies what percent not defective? It will be 99%, right? Because they need to add up to 100%. Of those coming from B, 2% will be defective, which means 98% not defective. And lastly, from C, 4% will be defective, which implies the 96% not defective. Okay. Now, from here we can actually compute, for example, a probability of, if you choose a chip randomly, from the probability that it is A and defective will be the product of 40% and 1%. Okay. Now remember, when you multiply percentage, never attack them from percent. Change them to decimal first. Okay, then from here you will see that this is actually 0.4%, and this is 0.004, right? Okay, and if I follow the same line of thought, the probability that it is coming from B and defective will be 35% times 2%. That will be 0.007, which is 0.7%. And then the probability that it is coming from C and defective, is 25% times 4%. Again, I change it to decimal. This is 25 here. That's 0.0100. Is that right? 47 places, 25 times 4 is 100, 47 places. So this is 1%. Now, part B, the question is, if a chip is randomly selected, find the probability that the chip is defective, regardless where it comes from. But the chance that it is defective may be because it comes from A, or come from B, or come from C, which we already prepared each one of them earlier, right? To be defective, it should be either this path here, or this path here, or this path here. Okay, that's why I will add those probabilities now. That will come up to 2.1%. Now, part C. Given a chip is defective, find the probability that the chip is from A. Probability that it is coming from A given that it is defective. Now, this is the same to say, if we remember the formula, that's probability that it is coming from A and defective divided by the probability that it is defective. Now, if we see what we have up there, the probability of A and D is 0.4%, and probability of D is 2.1%, which is equals to, I cancel the percent, move the decimal point, I will get 4/21. This is actually good enough, but if you want to make it into percentage, then it will be 4 divided by 21, this is in decimal, multiplied by 100%. That will be approximately 19.04, you see 76 there, let me make it 19.048%, if we want to make it into percentage. You can make it decimal if you want, okay, but because we use percentage since the beginning, then we keep it as a percentage. Okay, now lastly, out of 100 defective chips, find the probability that less than 25 are from company A. Of those defective one, given that it is defective, 100 defective ones, that less than 25 is actually coming from A. Okay, now actually we need to think this way. The probability that it is coming from A, given that it is defective, is 19.048%, right? Now, that's if one chip is defective. What is the probability that it is come from A for one chip? Now, once you have 100 defective chips, then we will have some kind of binomial distribution, right? Let X be the number of defective chips from A. Then this X will be binomially distributed with the number of trials 100, and the probability of success, in this case the probability that it is coming from A, is 0.19048. Now what they are asking us here is the probability that this X will be less than 25. Now there are actually two ways to do this, but because we have not learned what they call a normal approximation to binomial distribution, then for now we will use a calculator, which we will do this. X less than 25 means it is X is less than or equals to 24. Then from here I will use binom CDF of 100, 0.19048, 24. Okay, that's what I will do. Now if I use my calculator here, go to distribution, go to binom, CDF 100, comma 0.1904. Let me put a bit there. I happen to still have it. 761905, comma. I need 24. I get 0.91439. Okay, that's for number 4.